Hello, thank you for coming. This is the first, again, episode in a series of Ask Me Anything. If you're interested, if this is successful, if you're interested, if this is helping anybody, I will try to do it every week or at least every second week. Depending on your questions, I might bring in guests who might know something better than me. That will depend mostly on the questions in advance. Anyways, this is Ask Me Anything. There is nothing prepared in advance, no agenda. I will just go through your questions. And that means that you can start typing your questions in the comments right away, and I will do my best to answer them if I have the answer, if I know. Sometimes I don't. Also, some of you, quite a few, actually, a lot of you sent me questions in advance. So until you start typing your questions and we do this live, I'm going to go through some of the questions that you asked me in advance, right? This is opportunity for me to answer them or say I have no idea. And the first question we have, in no particular order, comes from, I cannot pronounce this, anyways. Is running databases on Kubernetes production ready? And assuming if it is, which operator to choose? Now, unlike most other people, I never thought that running databases in Kubernetes was not production ready. I think that it was production ready always. And that might sound very confusing, so let me explain. Databases, like anything else, run on servers, right? And they have networking and they have storage and what's not. So they're not really, no matter whether we are using Kubernetes or not, they're running on servers. Those are the same servers we would use no matter whether we are managing processes through Kubernetes API or no, right? So we could always, in Kubernetes, from day one, we could say, hey, you know what, run this on this specific server. So don't go left and right, don't move around the cluster, run it on a specific server, just as we would do with traditional way we were managing databases, right? We could have done in Kubernetes more or less the same as what we were doing without Kubernetes almost from the very beginning. So we could always do it. That wasn't a problem. So I would say, yes, it was production ready. Now, if we do with databases on top of Kubernetes or managed by Kubernetes API, the same things that we would do without Kubernetes, we would get the same result, but we would not get any benefits. So I think that the right question would be, were there and are there now benefits of running Kubernetes through Kubernetes, running databases through Kubernetes API or no? Because the end result is, in a worst case scenario, the same. They run on servers, right? And we can say run on this specific server no matter what happens. If it goes down, the database goes down, just as it was happening before Kubernetes. So again, the right question is, do we get benefits from running databases in Kubernetes? And I would say that for a while, the answer was no, right? You're not much better off outside in Kubernetes or managed by Kubernetes, to be more precise, than outside Kubernetes. But that changed. That changed mostly because some projects realized that you cannot just use core Kubernetes resources, like let's say stateful set, and put database in a container and say, now you're Kubernetes native, right? That's not the deal. Kubernetes from very early on was designed, not from the start, but early on got the mechanism to extend itself. And now we have databases or database servers, to be more precise, that leverage that heavily. And my example and answer to the second question would be CMPG or Cloud Native Postgres, right? They have their own CRDs. They don't rely on stateful sets, but their own controller manages pods, which are replicas of your database with everything that needs to be done, the way it should be done, and so on and so forth. And then there are other projects, just to be clear, but CMPG is my favorite, at least when Postgres is concerned. Now that we got to that point that actually projects created their own controllers that actually do work, instead of relying only on Kubernetes core resources, the answer to my question, not to your question, whether there are benefits is huge yes, right? We should definitely run them in Kubernetes now. We could run them before, just that there were no benefits. Now, yes. And my favorite, at least when Postgres is concerned, is CMPG, or Cloud Native Postgres. Okay, I'm going to mix questions sent in advance and those that are coming in. I'm a master student. Let me see. Okay, helped a lot. This is from Fundam XD, mostly words of praise. Thank you. I don't think that there is a question here. I might be wrong, so let me know in the comments. Thank you for thanking me. What else do we have from Minas? Progressive delivery, Argo rollouts. What's the best approach to handle DB schema changes or data migrations between the two versions? So there are two answers there. One is technical, another one is based on principle, rather, right? So let me answer this. Let me go with the second one. Your database migrations need to be always backwards compatible, right? Otherwise, if they're not, there is no way, there is no physical way how you can make zero downtime deployments, right, of your applications. Because if they're not backwards compatible, that means that you need to shut down your application, then upgrade the database or apply the new schema, and then put the new release of application. That's unacceptable, right? So I will assume for a second that the way you make schema changes and data migrations, if needed, is backwards compatible, right? And that means that you can postpone data migrations if they're backwards compatible. And that leaves us with schema changes, right? And in that case, assuming that it's backwards compatible, that the previous release of your application can talk to the new schema without breaking down, then basically, essentially, you would need to ensure that your schema is changed before you deploy a new release of your application. And as I said before, and so you would apply a new schema, and then you would start the process of rolling out a new release of your application. And there will be a period of time where you will have both the old and the new release of application in parallel. That period can be 1 second or 1 hour, depending on what you're doing. And during that period, you will have two releases, old and new, of your application, and both will be talking to the new schema. And if it's backwards compatible, it will work just fine. Keep coming with questions. This is awesome. So let me see one of the existing questions for a change then, from Buzzyfist. Is it a good idea to have a single cluster for utilities like observability and authentication in addition to workload clusters? Dapr staging. Depends a lot on what you're doing, and more likely than not, you might end up with both cases. So let me explain. There are some tools that simply work best within the cluster where there are workloads that they're doing something with. A good example would be Prometheus, right? Yes, you can run Prometheus outside of the cluster and then pool the information from some other cluster, but that simply does not work well, right? So Prometheus would be an example of, hey, every cluster would have Prometheus instead of having one central Prometheus. On top of that, we might start talking about scaled Prometheus like Talos and Cortex and so on and so forth. But Prometheus itself is an example of something that should run in your cluster together with your workloads, especially in prod, right? Staging dev, I'm not sure whether you need it there. Maybe. Anyways. And then there are some other tools that are better off if they work in a separate cluster. One example of that would be my project I work on, Crossplane, right? Crossplane is kind of a control plane. We run it and it manages other clusters and applications in those clusters and infrastructure resources like AWS, Azure, Google, whatsoever. It manages resources everywhere. And you can run it together with the rest of your workloads, but as long as you're big enough that you can financially afford it, you might want to have it in a separate cluster, right? That's one example. There are many examples. So it really, really depends on the tool and how it is designed. Most of the tools can work in both modes. It's just that most of the time they're better off one mode or another, right? I just gave one example, Prometheus, put it in a cluster with workloads, and another example would be Crossplane, put it in a separate cluster, assuming that you have slightly bigger system, right? If it's small system, then don't do a separate cluster, simply because every cluster, assuming that we are doing multi-zonal clusters, has an overhead in cost of three nodes for each cluster that you're paying for control plane nodes, for master nodes, right? So that's a financial overhead that simply doesn't make sense on very small settings, but when you grow bigger, yes, separate. Let's see now from the live comments, what else do we have here? Oh, a lot of them. Progressive delivery, Argo workload was the best approach to handle the... I answered that. Okay, sorry, trying to find a question. There are a lot of words of praise, not questions. Okay, so here's one. Transition of cloud computing to edge computing. What's your take on that? That falls into the category I don't know. I mean, I know, but not enough to comment on it, because that's unfortunately not my direct area of interest, expertise. Sorry, no answer to that question. And then another one would be in your cargo demo from Bernard. Every service needs to know all the available environments. Do you really think that this is the most scalable approach? So service team decide when to release to each environment. So first of all, I think that cargo is in infancy, so I wouldn't use cargo as example. I think it's a project that can go places and become very, very important, but that's not today. It still has a way to go. So I don't think that cargo is something I would rely right now. All right. And if I exclude cargo from there, I don't think that, I think that people should know about, more often than not, should know about the names of environments, not necessarily how they're set up and where they are and so on and so forth. So I do think that developers or teams around one application should be in control of what they do up to a certain level. So if you have a team in charge of application X, whatever that application is, I think that they should be choosing when to promote, because they know better than anybody else. But it should be simplified in terms like, hey, I want to promote to staging, or I want to promote to production. And I have no idea what is production or where is production, right? I do not necessarily know that production might be 7 clusters in different regions or only one cluster. That's not necessarily my concern. But so I need to know the names of environments, not necessarily where they are. I'm not sure whether that's your question. So let me know in the comments. Now going back to one of the questions from before, from Oliver Bereganzo, I cannot pronounce that. Sorry for that, man. What is the difference between Dapr and backstage? Why would we need one or the other, or do they complement each other, and in what way? So Dapr and backstage are completely different. I don't think that there is any connection between those projects, right? So the difference is that they're completely different and their goals are completely different. Dapr, short version of it is that Dapr is a way how we can manage connections to other stuff, like let's say databases or pub subs or whatever else we have, in a completely transparent way. So if I use Dapr, I can, inside of my code, I don't need to worry about which database I'm using, where is the database, how to connect, none of those things. In my code, I would just say connect to the database, and then Dapr would figure out what is the correct database, how to get there, how to authenticate to it, and so on and so forth. And all that depending on environments or the setups we have, right? So Dapr is basically a kind of a sidecar that is attached to our pods of our applications, And so when application says, I don't know, I want to talk to a database, those requests are going to that sidecar, and then Dapr itself figures out how to forward it there, how to authenticate and do whatever else needs to be done. Dapr, in a way, continues the tradition of removing things that are not business logic from the code of application, right? Just as we don't have SSLs anymore inside of our applications, they're external now. Similar thing with connections. It's an awesome project, but nothing to do with Backstage. And Backstage is, it's hard to define what it is. It's a front end of your platform in a way, right? So it's not a platform, it will be a portal of your platform or a service catalog, right? It's a place where we can gather the information from across the system. In some cases more, in some others less successfully, but we gather information and present it to people and enable people also to perform some operations. Like, hey, if you would like to create a new application, you can fill in this form, and then when you click this button, something will happen. And then what will happen is not necessarily the interest of that person, but hey, I got an application. And behind the scenes, we can design that data from that form is transformed to YAML, for example, pushed to Git, and then Argo CD synchronizes it, and so on and so forth, right? So it's a front end of your platform, or a service catalog, or whatever you want to call. So nothing to do with each other, or at least not that I know. Okay, going back to the live questions. Oh, I always lost the thread. Where was I? Okay, from Kugan. Here we go. How to distract myself off gaming. I think that I'm unable to focus myself on upskilling because of this stupid gaming addiction I have got. Please suggest, good sir. I have no good answer to that. I have periods of not playing any games for weeks or months, and then I got hooked into. Right now I'm playing Darkest Dungeon 2, which is an old game, and then what I do is I disconnect completely when I play the game, and then just finish the game. That might be 48 hours, and then I forget about it completely. But I don't have any better recommendation than that. So I'm going to go to the next one. Do you think there's special advantage to introducing proper workload identity mechanism like SPIFFE compared to plain MTLS setup? More often than not, I don't think that SPIFFE is, for most people, maybe for very, very large and advanced organizations, for most people, you don't want to deal with SPIFFE yourself, right? It's a very low-level tool, and you will find it already part of other tools that are higher level and more user-friendly. So, so for example, if you use Cilium uses SPIFFE, right, behind the scenes. So if you need workload identity, SPIFFE is great, but don't use SPIFFE. Just use one of the tools that are already using it together with whatever else they're doing, and Cilium would be one of the examples. Okay, going back to, this is great. Questions are coming like crazy. I love it. Back to the questions from before. Okay, this one is from Gardening. I cannot pronounce anybody's name today. Compare build tools like Gradle, Bazel, Dagger, and Nix, if that's possible. They're very kind of different. So Bazel I haven't used in a long, long time. I forgot even what it does, so I will skip that one. Gradle is kind of Java or Java-like tool, mostly used to build jars and then execute some tests and so on and so forth. I don't like, to be honest, I don't like tools that are specific to a language. I know that you can use Gradle outside Java, but I like more generic tools that are kind of work with anything. But yeah, Gradle, it exists for a long time. It's used to build stuff, and basically it's a task executor. Let's put it that way. And from that perspective, Dagger is the same thing. Dagger allows us to execute tasks. Do this, do that, and then do this. What makes Dagger special? I mean, there are many things that make Dagger special, but one of the things that makes it special is that you can do it in different languages. So think of it, Dagger being closer to Makefile or task file or just file, except that you can do it in Go, you can do it in Python. It's very tightly coupled with containers. which is awesome. We all use containers. So you can say that Gradle, there are many similarities, at least in what they're trying to do, Gradle and Dagger. Now, Nix is completely different thing. Nix is many things, primarily operating system. I will assume that you were not referring to operating system because most of us do not care about operating systems now. But the part of Nix that I really like and use heavily, that's packages. So Nix allows us to bring packages to any operating system, which is awesome. I use it basically with all my projects. Every single project I work on, either publicly or not publicly, has DevBox, because DevBox, think of DevBox as a wraparound Nix, so it's a user-friendly version of Nix packages. But still, the logic is the same. Doesn't matter whether it's directly Nix packages or the DevBox. But what I use it for is to basically bring project-specific tools I need. So I go to a project, to a repo, clone of a repo on my project. I just execute the DevBox shell, or if you're using pure Nix shell. And then a few moments later, I have all the tools I need to work in that project-specific versions. Like, hey, to work on this project, I need this version of Go, I need this version of JQ, YQ, kubectl, kind, etc., etc., etc. They're all ephemeral. So I work on that project. When I finished, I exit the shell, and all of those tools are gone. I mean, they're not gone. There is some cache somewhere, right? And then I go to a different project, again, Nix shell or DevBox shell. I get the tools I need to work on that project. So I have maybe only a few tools installed on my machine permanently. Everything I do now is Nix packages, and it's awesome. And then you can use those same definitions of packages for, let's say, workflows for CI/CD, right? So when I use GitHub Actions heavily. So whatever I use to work on that project, I use it in workflows. So basically my GitHub Actions in this case applies the same to anything, is the same. DevBox to bring all the tools I need, same tools that I use to work locally, execute whichever tasks you need to execute, go to the next one. So Nix, completely different from Gradle and Dagger. Gradle and Dagger are similar. Bazel, I forgot Bazel. It's been a while. Where was it? Okay, so now one of the live questions. What's next? Let's see. How to properly version multi-packages in Monorepos and their Helm versions. I want to use umbrella chart and version it too. I'm not a good person to answer that one, mostly because I don't use Monorepos. I don't like Monorepos myself. I don't like it. That does not mean that they're bad. And I definitely don't think that there should be an umbrella chart version. So actually it depends, right? I think that Monorepos are great if you have some kind of distributed monolith, something that is a monolithic application split into many smaller applications that are still the same monolith, and they need to be deployed all at once, right? And then some kind of umbrella chart might make sense, because it makes sense only if you need to deploy everything at once. And even then, I'm not sure that umbrella chart makes sense, because you can still have the Argo CD application pointing to all those individual charts. Those umbrella charts, I think, were very useful before GitOps to save us from typing Helm install 5 times, and we can do it once. But then once you automate, it doesn't matter. And once you start using GitOps, it matters even less. So I'm not very fond of umbrella charts. Maybe if you work locally and then you want to spin up everything with a single chart, but then probably your machine is going to say bye-bye and go bazooka, right? I'm also very fond of remote environments. So not my cup of tea, and I'm not very experienced with it. Maybe what I'm saying is completely wrong. Let me see. Another one of the questions from before, I'm just going back and forth. What are some of the best ways to get select features of service mesh with the complexity and overhead of one, for instance, adding MTLS or traffic splitting? Which features you need? I cannot answer that, really. It depends. There are some features that almost everybody who uses service mesh will always use, like MTLS is a good example. Kind of, if you're already using MTLS, why not? Traffic splitting already depends on, it's already a more advanced use case when you do something like Canary deployments or something like that, which is absolutely awesome. You should do it, right? But it tends to be complicated. I mean, it's easy to set up, but really reliably do it tends to be to assume that you're a bit more advanced and know what you're doing. So I cannot answer what are the selected features because it depends. The only one I know that everybody always uses with service mesh, and the only common denominator always, actually two common denominators in all setups that I've seen would be MTLS for internal communication and observability, which service meshes basically give you much more data of what is happening, at least on a networking layer, right? Okay, going back to live questions. Is it safe to expose a Talos API server to the internet? It's not safe. And then not only Talos, I think that it's not safe to expose any API server that is not supposed to be user-facing to internet, right? So the answer is clear, no. Now, in the past, that was a bit problematic because, hey, it's not safe to expose API to my system, not user-facing API, but to the system itself. But what can we do, right? We need it. Now, with GitOps, we don't need it, really, right? Because Argo CD and Flux, they're sitting in your cluster. They're pulling information. You don't have to access your cluster anymore, except in read-only mode. So you might still need to access cluster. Doesn't matter whether it's private networking or public, mostly to observe what's going on rather than to operate the cluster, because operations are now done with Argo CD or Flux. It's pooling information, so you don't need to, we don't need really to open it to anybody. You should probably have a way to access in break glass situation. You know, things happen that are unpredictable and then somebody needs to go and fix it. But outside of that, just don't expose Kubernetes API, including Talos, to public. There is no good reason to do it anymore. I mean, for development where we are playing around, yeah, why not? But for production, definitely don't. No. Okay, another one of the questions from before, from V. Rabbi. What do you hate about Kubernetes? That depends who the user is. I think that Kubernetes is amazing for a selected few of us, and then horrible for vast majority of everybody that I hate. So let me explain. Kubernetes is basically using, in a way, microservice or Linux-based approach that every single type of objects is a separate controller, separate definition, separate CRD or RD. And that makes working amazing because we can combine those very small and specialized pieces until we get exactly what we want, right? It's a similar story with AWS, right? They're very fractured, very small, but then we can combine them into something that is absolutely amazing, right? So I like that a bunch of specialized controllers approach and resource definitions approach of Kubernetes, because it allows us to get exactly what we want. But that's for 1% of us, 2% of us, right? Vast majority of other people, Kubernetes is just silly. It's stupid. They don't like it because it doesn't make any sense, right? So let's say Node.js developer. I'm a Node.js developer. I'm writing code, and then I want that code to become an application running somewhere. They tell me, yeah, you know, there is a deployment and a service, and the deployment creates a replica set, and replica set creates pods, and there is something called virtual service, and let me tell you about storage, and so on and so forth. That person freaks out because it doesn't make sense. All I want is to have something called application in my cluster, and I define application, and my code is running as application in that cluster. That's what people want. That's from back from the days of Heroku, right? So for people who are not dedicated to Kubernetes, Kubernetes doesn't make sense. And that brings me to what I hate about Kubernetes. And that's that From the early days, Kubernetes started as a baseline on top of which we build something that will be the final platform. And I don't think that we as industry got there yet. Kubernetes is very good at that base layer. There are a bunch of individual components that can elevate that layer to higher grounds or higher level of abstractions. That kind of makes sense, but we're not there yet. So my answer to that question, what I hate about Kubernetes is that it is visible. I think that for 98% of the people, Kubernetes should not be visible. It should be similar to hyperscalers to hypervisors in hyperscalers, AWS. I don't want to talk about hyperscalers, hypervisors. I don't want to see hypervisors ever again in my life. I just want an EC2 instance, right? And behind the scenes, you go and figure out what needs to be done. And I think that Kubernetes is going in that direction, and then I will not hate that part so much. But so far, Kubernetes is just too complicated for people who just want to run their applications, right? And especially for day 2 operations for those people. Okay, going back to the live questions. Okay, so question from, again, you have all very complicated nicks. What is the difference between Krakix and Crossplane? I haven't used Krakix much, so I'm not an expert. I definitely use Crossplane a lot. I think that Crossplane compositions. So Crossplane has managed resources, which I believe Krakix might not have, meaning that it extends Kubernetes with additional resources that match those in AWS, Google Cloud, Azure, and so on and so forth. I don't think Krakix has that. But then Crossplane has compositions, and Krakix has promises, which are conceptually very, very similar. And they're also similar to what Crow is doing. That's AWS project that was released a few weeks ago, maybe a month ago, just before KubeCon, and KubeVela, in terms that all those projects, including Krakix and Crossplane, have, among other things, mechanism to create your own interfaces, your own CRDs, and define what will happen when somebody creates instances of those or custom resources. So I think that's a similarity, but I cannot go in more detail because Krakix, I haven't used it much myself, unfortunately. I mean, I'll try it out, but not today. What else? Okay, let's do one more question from before. That's from, this person must be Polish. Shimon, Lukasz, and then I don't know what's the rest. How to use DevSpace with traffic mirroring to debug in production? Is it even possible? It would be nice if you can see the responses somewhere as well. That's the beauty of Kubernetes. You don't have to think about it in terms of DevSpace, right? Kubernetes is designed to combine different tools, right? DevSpace, as far as I know, and I'm not using it heavily, it's been a while, is basically simplifying the workflow, how you deploy, creates an abstraction on top, client-side abstraction on top of Kubernetes resources in a way, right? It's almost similar to Helm in a certain way. Anyways, it allows you a simpler way to define and run things in Kubernetes. But then for traffic mirroring, unless DevSpace added something since the last time I used it, DevSpace doesn't do it, but it doesn't matter, simply because DevSpace at the end of the day applies Kubernetes resources as any other tool would, like kubectl. And then you need separate mirroring. And there are a bunch of tools that do that. We talked earlier about service meshes, for example. Service mesh can do mirroring. There are many others that can do it as well, depending on which type of mirroring you need. Okay, live questions. Going back to live questions. Oh, time flies. This is cool. 54 of you. Okay, so from Milo, I think. Assume my only Kubernetes, and I haven't seen those questions, live questions in advance. I'm just putting them on the screen. Nobody knows what will happen. Assume my only Kubernetes cluster are in Azure, and I need to bring up an AKS in Azure. I use Terraform now, but if I wanted to switch to Crossplane, I need to have AKS deployed to run Crossplane from. Yes, so Crossplane runs in Kubernetes, and there are many reasons why that is a good thing. simply because, it's Kubernetes. It gives us all the good things, and it allows us to create custom resources, custom resource definitions, and our own APIs, and so on and so forth. Drift detection, reconciliation, good thing. Kubernetes, good things, right? And Crossplane needs Kubernetes to run. So, and then you have different options, right? You need to create a cluster somehow to run Crossplane, and then once that Crossplane is running, you can use it to create other clusters, including the future cluster where Crossplane is running. So you have. I'm going to go with 3 options. There are many others. One is that create the first cluster any way you like clicking buttons in Azure Portal or Terraform or whatever. Put Crossplane there, and from there on, use Crossplane to manage anything. Another way, the one I like more than the first, is you can just run Crossplane locally in kind, let's say a Minikube, and let Crossplane create the cluster, and then just move Crossplane with the same definitions to that real cluster, and then Crossplane will manage not only other clusters, but by itself, right? So you can run it locally, let it create a cluster, and then move those same Crossplane with same definitions to that cluster, and then it's auto-sufficient. It will manage itself. Or there is also managed control planes by Upbound, company where I work. I think that you get one control plane for free. I'm not sure. I think so. Anyways, Upbound gives you control planes that you can use to not create a cluster with Crossplane. Any of those 3 options, and there are many others, right? But ultimately, you need to have a cluster somewhere to run Crossplane. Just as in case of Terraform, if you do it seriously, you need to create storage before somehow without Terraform, and then you can and then use that storage to store the state of Terraform. I know it's a very big difference between creating a storage and a cluster, but also creating cluster is now easy in almost all hyperscalers. Okay, going back to one of the questions from before, please advise. We want to set up a Canary deployment for applications that are pushed via Nginx ingress, but which also interact with each other via Kubernetes services. And then there is a follow-up. Is it a good practice to use both Argo rollouts and Istio in conjunction with the ingress controller in this case? And one more, it's a long question. In theory, in this case, Istio can replace Nginx controller, but we are not ready to abandon Nginx. So if you want to do Canary deployments, there are, generally speaking, 3 ways. There are more than 3, but 3 that are commonly used. Whichever tool you use, let's say Argo rollouts or Flagger, it can manipulate the number of pods, it can manipulate ingress, or it can manipulate service mesh, right? Now, if it manipulates ingress, so let's say that you say 20% to this new release, then it would create 1 pod of the new release and have 4 pods of the old release, and then basically Kubernetes service would still be sending to all of them, but simply because of the number of pods, the percentages would be give or take correct, right? That's the worst option, because it's very hard to control the traffic simply by increasing and decreasing number of pods between 2 releases. But hey, if you have nothing else, that's what you do. Then it can manipulate ingress and say, hey, Nginx or whatever you're using, when the incoming traffic comes to that domain, send this percentage or whatever the criteria is over there and that percentage over there, right? And that gives you don't need to manipulate, you manipulate it on networking layer, and most ingresses should be able to do that. The problem with that is it works somehow. The problem is that works. That means that you can do Canary deployments only for external facing applications. So those applications that are exposed to internet can do Canary deployments. Internal applications that are talking to each other, no, right? And that's when, if you discard the manipulation of pods, that's when you get to the third option, which is service mesh. Like Istio has virtual service, for example, that allows you to say, hey, this virtual service, this percentage goes there, that percentage goes there, similar to what ingresses are doing, right? So you need service mesh if you have internal applications, unless you want to go with a silly way of manipulating pods. Just don't do that. Now, the last part of the question was, we are not yet ready to abandon Nginx. Now, I will assume for a second that if you're not ready to abandon Nginx, that means that you haven't adopted Istio yet, or not much, right? And if abandoning your ingress is a problem, then maybe Istio itself is not a good choice, right? Because as far as I know, for external traffic, unless you want to use some dark magic and witchcraft and wizardry, you need to use Istio Gateway. But there are other service meshes like Linkerd, right, which allows you to use service mesh internally together with essentially any ingress, right? Unless something changed recently, Linkerd doesn't have its own ingress like Istio has Gateway. So you can use it with Nginx. So if you haven't adopted yet Istio, you might want to choose Linkerd. They're both great, and with Linkerd, you don't need to switch to some different way to manage stuff. And by the way, we are getting Emma, which is a sub-project within the Cluster API initiative. And then we'll all be switching to it at some moment. That it will be a standard way how to do both ingress or incoming traffic, but also service mesh layer. Okay, going back to the live comments, there are many. Okay, let's see what else. What should, from Nagar, I think, I don't know. Where should someone start to follow along on your videos? Like, which videos should I watch first on your channel? I have no idea, man. I just publish things every week. Honestly, it's pretty much random. It's what I'm interested in, what I work on, and so on and so forth. So there is no order in my videos, and I don't even remember what I did more than a year ago. So I have no good answer to that question. Sorry for that. And then from Vladix, what are some good examples where Crossplane can be used except cloud resources? Okay, so there are theory and practice, right? Answers. In theory, for any type of managing any type of resources. Just this morning before this session, I was working on a project where I was using Crossplane to manage GitHub repositories and files in those repositories, right? And, initial files. Somebody wants to start working on a new project, and then Crossplane does something in AWS, does something in Kubernetes, but also GitHub, right? So basically, resources anywhere. It doesn't matter what it is. GitHub, Datadog, whatever, right? The only limitation essentially is there a provider for that? And if there isn't a Crossplane provider, then the next question is, can that something be defined as Kubernetes resource? If it can, then yeah, you can use Crossplane compositions for anything. I for example, there is no provider Crossplane for managing database schemas, as far as I know. But then there is Atlas that manages database schemas, and I wrap it into Crossplane composition. So any type of, let me rephrase that. Right, that will change in the future, but I cannot talk about it now. But right now, today, I would say that Crossplane is good to manage any type of resources that have a state, right? So it's not necessarily, it will not replace one-shot actions like, GitHub Actions or Jenkins workflows or Argo workflows. Those type of things, not necessarily today, because they're just executed once and never again, the same workflow. But to something that has a state, yeah, anything really. The only limitation is whether you can describe that as Kubernetes resource or no. Okay, going back to the questions from before. Let me see. To use both Argo rollouts and Istio. Let me see. When provisioning new Kubernetes clusters, do you prefer conventional infrastructure as code like Terraform, or would you use KCC or Crossplane? I'm biased. Crossplane all the way. If I wouldn't feel like that, I would probably change the project and move somewhere else. So Crossplane. But I'm biased, so take from it whatever you want, right? And then another one from before, James. Have you tried Istio Ambient Mesh yet? What do you think about it compared to traditional Istio sidecar proxies? I think that, so Istio had Ambient Mesh had a rough start, that when Cilium changed everything with their adoption of eBPF, Istio was no. and then Ambient Mesh started, but people did not take it really seriously initially. It was clunky and so on and so forth. So for a while, even Istio folks were saying, don't do it, right? Now I think it's good. It works well. It's just the question whether it's only a subset of just as Cilium is a subset of, has a subset of features of Istio. Similarly, Ambient Mesh has a subset of features. For most people, that subset is probably enough, and then Ambient Mesh is what you should use exclusively. We might enter into discussion whether you should use it at all or just rely on Cilium, since you cannot not have Cilium or some other CNI, but that would be a separate discussion. Anyway, it's good for what it does. Now you might come to the features or layers that you cannot manage with Ambient, and then you might need to combine it with sidecar approach. But I would say by default use Ambient unless proven that it's missing something specific you need. Okay, another one of live questions then. Crossplane can be used. Okay. Okay. Oh, Gabriel, does JenkinsX still ranks as a good solution for running pipelines? First, before I answer that, let me say, if people don't know, I was involved with JenkinsX. I was there and it was soon after it was born and until the last day, until it died, and I think it's mostly dead now. I heard that there is a few people that are still trying to keep it alive, but CloudBees, the company where most of the people who worked on JenkinsX gave up on it. We all moved somewhere else, including the Jameses, that were two James fellows. That created it in the first place. So we all moved somewhere else, including me and the authors of JenkinsX. So I don't think that I'm not following it. I might be completely wrong, but I don't think it's something anybody should use anymore. It was a great idea, though. Okay, now a question from before from Ramon. What are the main benefits of implementing a control plane with building a hyperscaler-based organization's cloud? Okay, if I have to say one thing, and choose only one thing, that's API, right? APIs are cornerstone of every public cloud that exists, right? API is how you talk to AWS. API is how you talk and how you talk to Azure, how you talk to Google. APIs are the contracts between consumers and providers. They're the most important thing. So the main benefit of building control plane is that, right? Have something that will expose your services through APIs, let people consume those services through APIs. Have some kind of controllers that will catch requests coming to those APIs and do something, right? Today that's Kubernetes. You might choose something else. Oh, we have 10 more minutes. Let's see who else. From Mr. Keck, I think. Hey, how can we take benefits from GitOps when I don't have access to Kubernetes? I cannot easily add CRDs. Clusters are managed by government. Now, I deploy everything with OpenTofu, including Helm charts. Now, first part of how can we take benefits from GitOps when we don't have access to Kubernetes? That's the point of GitOps. You don't need access to Kubernetes. You just need Argo CD or Flux running that Kubernetes cluster, and then you need access to Git, right? You push stuff to Git. Those tools pull those desired states to the cluster and make sure that they are fulfilled, that they become actual state, right? So I'm not sure I understood the question. Okay, I see that actually there is a follow-up here. How can I install Argo Flux CD at some time not adding anything to the cluster? Yeah, you need to install Argo CD or Flux to the cluster. That's basically, you need the cluster and you need to install one of those two. How? Doesn't matter. Helm install, kubectl apply, kubectl customize, any way you like. Now, the important part is that once you install it once, You don't need to update it manually, just to be 100% clear. From there on, you can say, hey, here are the manifests that define you. Go synchronize those as well. So you can have the definition of Argo CD itself in Git and point Argo CD to that definition, then it will manage itself. So you just need to that, and Flux actually, the installation process itself is doing just that. It is installing itself in a cluster and then automatically creating some files in Git and pointing itself to that Git, and from there on you manage it using Git. So I cannot tell you how to get access to that cluster. But actually, I saw in a previous question, now I deploy everything with OpenTofu, including Helm chart. So you have access to the cluster. For a second, I thought that you cannot even access the cluster. You obviously have access to the cluster because OpenTofu runs on your laptop, right? Or wherever it's running. You just need to install that one tool, Argo CD or Flux, and from there on, you don't need access to the cluster anymore. Okay, one from the before then. Let's see this one, the next one. No criteria, everything goes. If you're a solo DevOps in a team, what steps do you usually take and how do you approach learning a new technology? I mean, it's hard to say when people say DevOps, they mean many different things, right? What I can answer is how do you approach learning a new technology? That depends on the experience, right? If you're inexperienced, then it's hard because technologies depend on other technologies, which depend on other technologies, which depend on other technologies. We almost never invent something new from scratch, right? All the new tools or new features and stuff like that, they're built on top of something, either some other tools or some other processes or some other experiences from before. So beginnings are very hard because let's say that you want to learn Kubernetes, then you cannot just learn Kubernetes. You need to learn containers first, but you cannot just learn containers. You need to learn Linux, but you cannot just learn Linux. You should know, and so on and so forth, right? All those things we do today are stuck on each other. And then you basically need to learn everything to learn something. So I don't have the answer because it's been like 40 years, 30-something years since I was beginning. But then once you gain some experience, then it becomes easy because precisely for the same reason, because things are built on top of each other, right? So if you're already familiar with Linux, actually Docker containers are relatively easy, straightforward. There's not much to learn. Once you learn those things, learning cloud is becoming easier, and learning Kubernetes is becoming easier, and so on and so forth. And then once you get on top of Kubernetes, then it's smooth sailing because all those tools are following the same principles. When I see a new Kubernetes native tool, usually I can pick it up in an hour or two. I mean, it takes much more than that to master it, but to pick it up and be somehow know what the heck is going on and making mistakes, it's relatively easy if you have that prerequisite knowledge, really. Which is hard to get. So, but it's been a long while since I was young. Okay, let's see one of the questions live. What are your thoughts on a cluster that has nodes connected via VPN? I think that VPNs should disappear. I hate VPNs. I never had a good experience with VPNs. I'm working on a project that abstracts VPS cloud providers. The goal is to provide users with the cheapest compute there is. I guess that Medium, you wanna show me that project, how it feels from your message. If that's the case, just ping me on LinkedIn or Slack, or I'm not on X anymore, but then Blue Sky as well. I'm easy to find. Ping me and then show me what it is. I'm always interested to see. Another one from Joanna. I'm a small team, 7 people, but the product is big. We have scalability issues with workloads using Celery. Should we use Kubernetes and KEDA to scale Celery workers? Oh, Celery sounds familiar. What is Celery? It's been a while. I know that I used something called Celery a long time ago, but I cannot remember what it is. Rana, if you can explain, tell me what Celery is, I'm completely lost here. I'd love to answer it, but I don't know. What I can say is that Kubernetes is the standard now. Kind of. The only reason why I believe somebody should not use Kubernetes, two reasons. First, if you have something ancient that you haven't touched in decades, and then you just keep it there, like some mainframe, something kind of, you forgot it for 10 years, then you can keep forgetting it, right? And the other reason why somebody shouldn't use Kubernetes, if you want something simple like Fly.io, so managed services are even better than Kubernetes, right? Azure Container Apps, Google Cloud Run, right? They tend to be expensive and maybe less flexible, but they're great. For everybody else, Kubernetes is a standard now, right? It's the first time in industry that we have standard that absolutely every single vendor in the world adopted. So go for it. No reason not to do it. Another one from Pretty Basic. And Joanna or Joano, I'm not sure. If you can let me know in the comments what salary is, I need to check it out. So from Pretty Basic, how to GitOps your secrets. That's relatively easy. Right? Secrets, keep secrets in some secret store. I don't know, AWS Secret Manager, Google Secret Manager, wherever you keep secrets, keep them there. It's fine. And then use external secrets operator to define it as Kubernetes resources, put it in Git, and then when it's synchronized to the cluster, it will pull the secrets and do whatever needs to be done with secrets. So external secrets operator, or ESO, absolutely amazing. Use it. There are some other tools that, what's the name? My brain stopped, where you could encrypt secrets. My brain stopped, and then push it to Git, but at the end, I don't think it worked well. External secrets operator is awesome. Use it. Okay, one from before then. How should we organize? Okay, so this is from before. From Amoenus Dev. How should we organize and use Q for both Kubernetes and general development? I strongly believe, I love languages like Q. Personally prefer KCL, but still the logic is the same. Q, KCL, any other. I think that when you do something complex, I think that they're so much better than writing pure YAML. If you have 10, 20, 30, 50 lines, write YAML, don't use Q, right? When it's above that, you need something, whatever that something is. And Q is one of the choices, and it's good. And so what I do with all those tools, I always write my definitions in those tools, but then in my workflows, in my CI pipelines, I output them as YAML and store them in Git. So the way I organize it depends whether you're asking about organization of the output or the code itself. Output, yeah, I store it in Git. I never do directly apply to the cluster. I store it in Git and then Argo CD synchronize it. If the question is how to organize code, in case of Q, while I was using Q, I'm not anymore. I organize it in whatever way Timoni propagated. So I use Q for Kubernetes with the project Timoni that comes from Stefan, which is the person behind Flux and Flagger projects. Absolutely awesome. I strongly recommend to check Timoni if you're using Q for Kubernetes. Okay, one of the live questions. So we have 2 more minutes. I will have to disappoint everybody. I need to close at the top of the hour. So one more question. I will collect all the questions that are left unanswered and put them on my list for the next stream, okay? And you keep putting them in any other way, direction, whatever you do. I'm going to try to answer them all. So last question. What do you think about AWS announcing CRO, Kube Resource Operator, instead of contributing to Crossplane? I'm not sure whether to say anything. I will publish a video about CRO in a few weeks' time. I will leave you with only one word until then. I don't want to spoil the video, and that is why. Why does CRO exist? That's the question I'm asking, and I don't see the answer. So I think it's a very very green tool that I don't understand why it was created and what it solves. But anyways, a few weeks from now, I will publish a video, honest opinions about Chrome, and whether I will stay with Crossplane. So keep tuned. Thank you everybody for joining. This was fantastic. I feel lonely being alone here, but fantastic. Anyway, I will collect all your questions and put them to the list for, I think next week I will be traveling, but week after next, we will even have a guest that will help us out. And I will also, if there are some unanswered questions from before, I will keep all the questions. Sooner or later, I will answer them. I go in chronological order, so first question gets answered first, and so on and so forth. So keep them coming. Thank you so much. Click the subscribe. Do the stuff that you do in YouTube. Thank you so much. See you in the next one. Cheers.